Hello everyone, today we are going to learn about data structure. This presentation introduces the basic concepts of data, informations and different types of data structures used in a computer science. A data structure is a particular way of storing and organizing data in a computer so that it can be used effectively. It is an implementation of abstract data type also known as ADT. Data structures helps us to manage large amount of data effectively and improve performance while processing information. Next, moving on to the next slide, we are going to see about the concepts of data and information. Data is a collection of raw facts and figures. It does not have any proper meaning on its own. For example, we can include a student admission details as an input or citizen records collected during services. So next, moving on to the information concept, when the data is processed and organized, it becomes information. For example, stored student data can be used as a print address label. Similarly, census we can take as data. Census data can be used to calculate a population literacy rate. Thus, the process data is also called as information. Next, moving on to the next slide, we are going to see about the concepts of types of data structure. Data structures are mainly classified into two types. One is primitive data structure and another one is non-primitive data structure. Uh, in non-primitive data structures are divided into two types. One is linear data structure and another one is non-linear data structures. Next, moving on to the topic primitive data structures, we have already seen that in this flow chart. So that primitive data structure consists of four types. One is integer, float, character, pointer. These data types are called a single type of data. So next, moving on to the non-primitive data structure. Non-primitive data structures are divided into linear data structure and non-linear data structure. Data elements are arranged sequentially or linearly, where each element is attached to its previous and next adjacent elements. In static data structures and dynamic data structures are the kinds of linear data structure. So the memory size will be fixed in static data structures, but in dynamic data structures, memory is not fixed. Memory size is not fixed. So in static data structures, it is easier to access the elements. For example, we can take it as array as an example for static data structure. In dynamic data structures, it can be randomly updated during the runtime, which may be considered efficient concerning the memory and complexity of the code. We can take it as an example of a queue on stacks or the example of dynamic data structures. So next, we are going to see about the nonlinear data structure. Data elements are not placed sequential or linearly. Con transfers all the elements in a single run. So we can take it as an example of a nonlinear data structure as a trees and graphs. So next, moving on to the topic called need of data structure. And data structures are needed to store and manage data efficiently. They help in reducing complexity, improving processing speed and organizing large amount of data in a structured way. Next, we are going to see about the concept of array. An array is a collection of elements stored in contiguous memory locations. All elements in an array are of the same data type, and array allows easy access to elements using indexing values. So some operations are using in this array concepts. One is searching, sorting, inserting and traversing, reversing and deleting are the operations which are using in the array concept. The first element of the array is indexed by the subscript of 0. Next, we are going to see about the topic called a stack. So in the stack, a stack is a linear data structure that follows the principle like last in first out. The main operation or using in this stack concept is push and pop. We can include an example like media player playlist and arranging plates in a stack is an example of stack concept. So next, we are going to see about the concept of queue. In this queue, one principle follows by the data structure, that is first in first out. The main operations are enqueue for insertion and dequeue for the deletion. So we can take as an example of train engines and queues in the banks or the examples of queue concept. And we are going to see about linked list concept now. So in this concept, linear data structures where elements are stored in a nodes. So each node contains data and the pointer to the next node. So linked list allows dynamic memory allocation. Some examples we can include in this linked list. One is social media feeds and image viewer. So there are four types of linked list are there. One is singly linked list, doubly linked list, circular linked list, and doubly circular links are the types of linked list. So next we are going to see about the concepts of tree. A tree is a nonlinear data structures that represent hierarchical relationships. It consists of nodes connected by edges with one root node as a top. So topmost node we can call it as a root node or parent node. So next one is subnodes. We can call it as a child nodes. So nodes are connected via edges. So some terminologies in or in the tree concept. One is node, root, edge, height of tree, and degree of the tree. So these are the terminologies using in a tree concept, and levels in a game development is an example of tree concept. And four types of trees are there. One is a binary tree, second one is binary search tree, and third one is AVL tree, and finally B tree is an types of tree concepts. Next we are moving to the concepts of graph. This is also one kind of a nonlinear data structure, and consisting of vertices and edges. It is used to represent networks as a social media connections or route maps. So some terminologies are used in a graph. So that's all. Path, degree, adjacent vertices, connected components are the terminologies of graph. So we can include World Wide Web as an example for graph concept. So thank you for this session. This concludes the introduction of data structures, and these basic concepts forms the foundation of understanding advanced data structures. So thank you once again. Thank you.